Okay, Algebra 2, this is section 3-6. Yesterday we did, or last section I guess, we did, in section 3-5, we did completing the square, then we did, before that, factoring and all that good stuff. This is the note sheet for 3-6. I want to flip onto the backside. Just one really quick thing. This is the concept summary for quadratic equations. So we started off this chapter by graphing quadratic equations by doing like the vertex and the axis of symmetry and doing all of those things by graphing, okay? And now sometimes that can be useful, right? Sometimes you can do that and sometimes you can plot points, but sometimes your points don't cross correctly and you'll have to do, some estimation and stuff. So then we went on to factoring and we said, okay, if we can factor it down and we can set those equal to 0, then we're good to go, right? We had those factoring methods like the GCF, and we had a simple trinomial, and we had a complex trinomial, and then we had difference of squares. Those were all factoring methods that were supposed to help make life a little bit easier for us, okay? And then we had the square root property and completing the square. These two kind of go together, okay? Completing the square was like completing the blank, where you put the x squared plus whatever x plus blank equals some number plus blank. And you were trying to solve by completing the square. And you will notice that factoring sometimes works, right? Factoring sometimes works, sometimes it doesn't. Completing the square, though, will always work. You can always do it, even though you'll end up with some ugly decimal numbers that you're adding to both sides, you will always be able to complete the square. In addition to that, the quadratic formula, which people actually probably like more than completing the square, they're able to remember it a lot more. This one will always work as well, okay? So this is the kicker. The quadratic formula, if you forget how to do all of these, all of those methods, if you forget how to do all of them, you will always be able to use the quadratic formula instead of doing one of those methods. So if you're going to forget one, don't let it be the quadratic formula, okay? Quadratic formula, you have to memorize the formula, but tomorrow when I come back, I'm going to play for you a song, and some of you guys have probably already seen it before, but I ruin a song for you, Adele's Rollin' in the Deep from, God, 10 years ago. I ruined that song for you because we play the quadratic formula, and it's to the beat of Adele's Rolling in the Deep, and that will help you to memorize the quadratic formula. So, moral of the story, if you're going to forget any one of these, don't let it be the quadratic formula. You need to always remember that guy, okay? So, let's go to the front side. What is the quadratic formula, okay? This guy right here. He's a big, long thing. You probably have had him before in Algebra 1, but memorize him. We're going to have to remember what he does, where he comes from, what he looks like, okay? There's a riddle that goes with the quadratic formula. I'll play the song for you tomorrow, but if it helps, you can memorize the riddle, okay? The riddle goes, it's very stupid, so just bear with me. A negative boy, negative b, couldn't decide, plus minus, whether or not to go to a radical party. That's a radical symbol. But being square, he decided not to go and missed out on 4 awesome chicks. Negative boy couldn't decide whether or not to go to a radical party, but being square, he decided not to go and missed out on 4 awesome chicks. The party got over at 2 a.m. Okay, so we have this quadratic formula. That's great. Now, what are we solving for when we're doing the quadratic formula? What are we solving for when we're doing any one of these 5 things up here, right? We are solving for the places where he crosses, right? All of these are going to be parabolas. We're trying to find those places. Now, we know that sometimes he won't have 2 places he crosses. Sometimes he will only have 1. Sometimes he will not have any, right? Okay, and what do each one of those look like according to the quadratic formula? I don't know. We'll find out. So, on this first one, we know that we do have 2 rational roots, okay? So we are going to have the scenario where this happens, right? Okay? We're going to have 2 of them. We're going to try to solve for what they are, all right? Now, step 1 for the quadratic formula, they have to all be on the same side and you have to set it equal to 0. So this 11 needs to be bumped. X squared minus 10x, the 11, when you bump him to this side, is minus 11, equals 0. Now we're ready to go. Okay, So in the quadratic formula, this right here, you'll notice we have B's and A's and C's and all that stuff. And what does ABC stand for? We've talked about this before. ABC are the numbers that are in front of your x squared x in numbers. So A is this guy right here. He is a 1 if there's no number there. B is this number right here, including the negative. C is this number right here. You do not include the x's and the x squareds. They like get detached, okay? So A is 1, B is negative 10, C is negative 11. All right? Now I just enter that into my formula here. Negative B. So I have negative, and B is negative 10. Negative, negative 10. All right? Which will turn that to a positive, but we'll just hold on for just a second. Okay? So negative, negative 10 plus and minus the square root of B squared. Okay? If I take B and I square it, negative 10 squared will be positive 100. I'm going to go ahead and write 100 in there. Minus 4 times A is 1 and C is negative 11. It is so important that you write all your work out because otherwise you're going to be super, super wrong. Okay? All right, and then all over 2 times 1. All right, so now we have negative, negative 10. That's positive 10. 10 plus and minus the square root of 1. So this guy right here, negative 4 times positive 1 times negative 11 is going to give me a positive 44. So that's going to be 100 plus 44, which is 144. 144. All over 2. Because 2 times 1 is 2. All right? Now, you will notice that the square root of 144, maybe you know this, maybe you don't, but square root of 144 comes out nicely. It's 12. Right? 12 times 12 is 144. So, this is really nice because I have 2 answers. The first answer is 10 plus 12 divided by 2, and the second answer is 10 minus 12 divided by 2. Right? 10 plus 12 divided by 2, this would be 22 divided by 2, or 11, and 10 minus 12 divided by 2 is negative 2 divided by 2, or negative 1. So, over here, in my place where I have my parabola, you notice that this is negative 1, and this spot over here is positive 11. Okay, not drawn to scales, but bear with me, okay? So those are the 2 places, and we found that by doing the quadratic formula, okay? All right, same thing again, example 2, except we're going to have 1 rational root. Okay, so he's going to just be touching, all right? Now, everything is on the same side like it's supposed to be, set equal to 0, so we can just dive in and do ABC. ABC. A is 1 again, B is 8, C is 16. 1, 8, 16. Okay, you probably can do this after a little bit of time without writing out ABC, but it's good for the first couple times to at least just write it out. Okay, so we start with negative B. Negative B, negative 8, plus and minus the square root of B squared. That would be 8 squared, which is 64, minus 4 times A is 1, times C is 16, all over 2 times A, which is 1. Okay? All right, now we have here negative 8 plus and minus the square root of negative 4 times 1 times 16 is going to be a negative, and I think that number is 64. Okay, well, wait a second. 64 minus 64 is 0. All over 2 times 1 is 2. Okay, so here you'll notice, so we have negative 8 plus the square root of 0 is 0, all over 2, and then we have negative 8 minus 0 divided by 2. Okay, well, negative 8 plus 0 divided by 2 is just negative 8 divided by 2, or negative 4. And negative 8 minus 0 is going to give me the same answer, right? So in that case, I only have one solution, and that's going to be at negative 4. 1, 2, 3, 4. And he's going to touch and he's going to cross right there. Okay? So using the quadratic formula, we found he was negative 4. He's very easy to locate where his zeros are, and we're good to go. Okay? Now, irrational roots. Okay? These are going to be roots that are kind of ugly. They're just come out disgusting, but it's not going to be an imaginary one yet. These are going to be your imaginary ones. Imaginary. Okay, so A, B, C. This one's all ready to go for us. 2, 6, and negative 7. Make sure the negative goes with him. 2, 6, negative 7 are my numbers. All right, and then I start with negative b, negative 6. Plus and minus, this is the same process again. B squared is 6 squared, which is 36. Minus 4 times a is 2, times c is negative 7, all over 2 times a, which is 2. Okay, so there's that. And then I just simplify. So I have negative 6 plus and minus 36, and then I have negative 4 times 2 times negative 7. Okay, negative 4, 2, and negative 7. Well, this right here, negative 4 times 2 is negative 8. And negative 8 times negative 7 is positive 56. Okay, so 36 plus 56, if I add those two together, will be like, I don't know, 92 or something like that, the square root of 92. And that's all over 4. Okay, the square root of 92 over 4. Now, the square root of 92 does not come out nicely, but if we try, let me see if I can find my calculator here. The square root of 92, okay? Since it does not come out nicely, we're just going to leave our answer like this. Kind of like what we did with the completing the square. If it doesn't come out nicely, we just leave our answer. But just kind of think about how many answers are represented in that problem there, okay? Because we have the positive and the negative, there are really 2 answers, okay? And the square root of 92, if I do 92 square root, this is really like 9.6, okay? So if I think about what this looks like as a decimal, this would be negative 6 plus 9.6 divided by 4, and negative 6 minus 9.6 divided by 4. It's going to give me some decimals, and that's okay. So, let's see, 3.6 divided by 4 is 0.9, I think, 0.9. 0.9 is going to be one of my solutions. And then, let's see, 15.6 divided by 4 is negative 3.9 is the other one, okay? So, just because he didn't come out as a whole number like these two, I'm still going to have 2 solutions. He's just going to look really ugly. So, he's going to be at negative 3.9, so about here, and excuse me, positive 0.9, and he's going to look like this. And he's a smiley face because it's positive. I think all of these are smiley faces, okay? So, again, the answer, we're just going to leave our answer like this. So this is the true answer right here. But just thinking about what that means, you have these 2 solutions, okay? Those 2 solutions. All right, and then we have, last one, example 4, we have complex roots. We're gonna skip this discriminant part until tomorrow, and I'll alter the instructions here in just a second. So, complex roots. First, again, we want to kick that 10 to the other side. Okay, all the rest of them, or the last 2, were fixed, but we want to kick that 10 to the other side. So we've got x squared minus 6x. He will be plus 10 equals 0. Okay. So again, we're looking for where he crosses the x-axis by using the quadratic formula. So I'm going to do my ABC, A, B, C. Okay, and then we are going to fill in our numbers. So A is 1, because there's no number in front of there. B is negative 6. Make sure you tag the negative along. And C is 10. Okay. All right, so now plugging those in. So we have negative B. And B is already negative, so it's like negative 6 plus and minus the square root B squared. Okay, anytime you take this and square it, it will become positive. Right? If it's already negative, it will become positive when you square it. Minus 4 times A is 1, and C is 10. Okay, all over 2 times A, which is 1. You're going to have this formula burned into your brain. All right, so let's simplify him. Negative 6 is positive 6. Plus and minus, let's simplify the stuff that's on the inside. So I deal with this part first. 4 times 1 times 10, negative 4 times 1 times 10 is going to be negative 40. So I have 36 minus 40. Right? 36 minus 40 is going to be negative 4. Okay, all over 2 times 1, which is 2. Okay. All right, now the square root of negative 4 is a negative number. We can't take square roots of negative numbers. But you might remember from when we did complex numbers, the square root of negative 4 is like the square root of negative 1 and the square root of 4. Okay? And the square root of negative 1 is I, and the square root of 4 is 2. right? So really this thing right here is 2i. So we have 6 plus and minus 2i all divided by 2, okay? And what we're going to do is, since all three of those numbers are divisible by 2, we're going to go ahead and divide them out. So 6 divided by 2 is 3, 2 divided by 2 is 1, and 2 divided by 2 is 1 again. Okay, so we have 3 plus and minus 1i all over 1. Okay, now, if you don't like to write the 1 in front of there, you can just write this as 3 plus I. Like this, 3 plus I, you can write it like that, rather than writing 3 plus and minus, no, plus, minus also. 3 plus and minus I, or 3 plus and minus 1i all over 1, okay? So that's what that means. Now, again, we still have two solutions here, but they're like imaginary solutions, which means this guy is not going to touch. He's going to be a parabola that's above the x-axis, and he's not going to touch this x-axis here, okay? So that's the reason why imaginary numbers exist, is because we have to have an algebraic solution for the zeros, and there are no zeros, so we have to have a solution for that, and they write that as an imaginary number, okay? All right, so we're going to talk about the discriminant tomorrow. It's a very easy concept, but I don't want to overload you too much. So we're going to talk about discriminant tomorrow, and then I'll show that video for how you can memorize the quadratic formula. I did leave you a homework sheet, okay? And it says, okay, it says A, B, C for each one of these, 1 through 12, A, B, C, okay? A says find the value of the discriminant. You're not going to do that yet. Don't cross it off. We're going to do that tomorrow. And then describe the number and types of roots. We're going to wait and do that tomorrow. But in part C, it says find the exact solutions using the quadratic formula. You're going to do all of the part C's for 1 through 12, okay? Now, be careful, because some of these you'll notice, like on number 3 and number 5 and number 6, okay? 3 and 5 and 6 are only 2 pieces, so where's the third piece, okay? You have to determine which piece is missing. So this one has an x squared. He has an x, but he doesn't have that additional number on the end, right? Like his c value is gone. So you might want to rewrite this as 3x squared minus 2x plus 0. And then that will give you your A, your B, and your C, okay? For number 5, you have to decide which part is missing there. Well, we have a 5x squared, but where's the x value? There's no x, right? So we have to put plus 0x minus 6. So A is going to be 5, B is going to be 0, and C is going to be negative 6. So be thinking about that if you have pieces that are missing, okay? All right, and go ahead and do the quadratic formula for solving each one of these out, okay? We'll do parts A and B tomorrow, okay?